Now we do question number 8. Question number 8, we can see we have a linear function and we have a quadratic function. So he's asking you to find g of f of x. So the composition of g and f function, it tells you that you have to throw f in g. So what is the g function basically? That is x squared plus x. So in the place of x, you need to leave the brackets open and close here, plus open and close the bracket. In the place of x, you need to write f of x. And over there we have x, but we need to write f of x. What is f of x equals to? That is equals to 2x minus 1 and 2x minus 1. So 2x minus 1, 2x minus 1 is 2x minus 1. Multiply them, 4x squared minus 2x plus 1 plus 2x minus 1 minus 2x plus 2x cancel, plus 1 minus 1 cancel. So I get 4x squared minus 2x. Now there are two ways to convert it into completing the square form. First is the manual way. I told you need to write 4 outside, x, all. What is the sign here? Minus. This number always divided by 2, so the answer is 1, divided by the number which is seen over here, 4 whole squared, minus whatever you see here, you need to write it here under the square, times with again 4. So 3 times you need to multiply it. Clear? Do we have any number outside? This is 0. When I simplify it, I'm gonna get 4x minus 1 over 4 whole squared, minus, after simplification it will give you minus 1 over 4. From here I can easily write the vertex. Okay, but the completing the square form is done. If someone wants to use calculator, you remember guys, the coefficient of x squared is 4, enter. Coefficient of x is negative 2, enter. 0, enter. First value ignore, this is the x-intercept. Second value ignore, this is the y-intercept of the vertex. Third value is 1 over 4. So vertex I want to write 1 over 4 is my vertex. Fourth strike on the equal will give you negative 1 over 4. Can I write from here my completing the square form? X, this is plus 1 over 4, I write minus 1 over 4 and copy it as it is, minus 1 over 4. What was a? A was 4, so write 4 outside. Is it matching? Yes, it is matching. So we are done with completing the square form. Let's move to the question number 9. He said find the inverse of each function. To find the inverse of each function, we need to write y is equals to 3 minus x and try to make x as a subject. So x goes to the left and y comes to the right. So 3 plus y. Once you confirm that your x is made as a subject, so your f inverse of x, inverse of f of x is 3, and replace y by x since we used here x. Clear? So the dome of the function f is real numbers. In some later state he will ask you about inverse function, domain and range. Inshallah we will talk about it. So this is the function, guys. Let y is equals to 6, 4x minus 1. So y is equal to 24x minus 6. And I want to make x as a subject. So 5 plus 6 is equal to 24x. The y plus 6 over 24 is equal to x. Now what is this? I can easily write my f inverse of x is equals to, in the place of y, write x. So this is x plus 6 over 24. This is my f inverse of x. Now y is equals to 2 over x plus 5. Do the cross multiplication, or you may uh, change their positions. Yani x plus 5 goes here and y goes down, and then sends 5 to the other side. So x is equal to 2 over y minus 5. If you don't want to use this way, you want to multiply them together. So it becomes xy plus 5y is equal to 2. Then you can send 5y to the other side. So xy is equal to 2 minus 5y, and then x is equals to 2 minus 5y over y. This can be also inverse function. Both of them are equal to each other. So f inverse of x is equals to 2 over x minus 5. Maybe you think why this answer is not equal to this. Look at that. 2 over y minus 5y over y cancel. Look, this is the same answer which we got it over here. Just you need to write f inverse of x, replace y by x, so 2 over x minus 5. Quadratic function, when he gives you, basically, if I have a quadratic function like that, if someone asks you find h inverse, your answer will be no, I can't. As long as I have a u-turn, I cannot find f inverse, doesn't exist. That's why the examiner will give you the restricted domain in which there will be no u-turn. There is a second method. If you draw any horizontal line, if it cuts the graph at more than one point, then again f inverse doesn't exist. So suppose I want to see the sketch. Is the sketch having u-turn? 3x squared plus 1. So I can write it as 3x minus 0 whole squared plus 2 in this much more refined form, quadratic form, completing the square form. So the vertex is 0, 2. Supposedly, if I want to draw the graph, so 0, 2, 0, 2. So this is the vertex. Okay. And vertex is done, and the face is upward, so the graph will be like this. No, what is the domain given? The domain is x greater than equal to 0. The domain is this. This is your domain. It means I'm gonna draw only this part of a graph. Guys, is there any u-turn? Horizontal line test passes, so f inverse exists. Don't worry. So I can find f inverse very quickly. Y is equals to 3x squared plus 2. Send the things to this side. So y minus 2 is equal to 3x squared. Y minus 2 divided by 3 is equal to x squared. Send the square roots with plus minus sign. Here the trick is applied. Did he use the right hand side of x? If he uses the right hand side of x, it means that, because all of my outputs are positive, I cannot use the negative sign. So my inverse function is, if you write plus minus sign, that would be wrong. So plus x minus 2 over 3, that is the inverse function. Now I want to find f inverse function for this. Y is equals to 2 over x plus 1, change their positions. So x plus 1 is equal to 2 over y, send the plus 1 to the other side. So x is equal to 2 over y minus 1. So f inverse of x, or g inverse of x, is equal to 2 over x minus 1. That's all. Square root y is equals to square root of x minus 3. Send the square root to the other side, becomes y squared. So x minus 3. Now y squared plus 3 is equal to x. So this is your f inverse function, or h inverse function. So h inverse is equals to x squared plus 3. Now he gave you a quadratic function, and the domain is from 0 to 2. We need to convert it into completing the square form. Let's study how to write completing the square form. The function is x squared plus 2x minus 1, and the dome is from 0 to 2. The manual technique, what is the number here? 1. X plus divided by 2, it is 1 divided by what? 1. No need to write it. Squared minus whatever the number seen here, minus 1 squared, times with 1 and minus 1. So what is the answer? We got it, x plus 1 whole squared minus 1 is minus 2. If you want to check from the calculator, how? Go to the equation mod, enter 1, enter 2, enter negative 1, ignore the first, ignore the second, third is minus 1, the vertex is minus 1 x coordinate, fourth stroke is negative 2, this is negative 2. Did you see, guys? I have written here minus 2 and this is minus 1. Here I change the sign. So from the calculator you can write the completing the square form. but I think it's better you show the step. So the vertex is done. Now, after finding the vertex, I need to know what is my domain. My domain is from 0 to 2. So 0, and where was the vertex? Minus 1, minus 2. This is minus 1, and this is minus 2. The graph is here. So definitely when I draw the graph will be drawn like this. He's using the dome from 0 to 2. So 0 to 2 is from here to here. This is 0 and this is 2. So at 0 there will be some answer. If you subtract that is minus 1. And 2 I have some answer. Let me check what is that. 2 substitute 4, 4 plus 4, 8, 8 minus 1, 7. So how many values, how much y-axis was consumed? From 7 till minus 1, minus 1 till 7. That is the range of the function. So f of x is between minus 1 till 7. Now I want to find the inverse function. You cannot find the inverse function if you have a standard form. First, it should be in completing the square form. That's why the examiner has made you to find completing the square form first, because now he can ask you the inverse function. Your question comes to me, Mr. Omar, how come I'm finding the inverse function of a quadratic function? So my answer will be, the graph is like this. Is there any u-turn in this graph? Is there your horizontal line test pass? Oh yes. So no objection, you can find inverse function. So how to find inverse function? Y is equals to, y is equals to, come on, y is equals to, completing the square form, which is x plus 1 whole squared minus 2, and send it to the other side. Y plus 2 is equals to x plus 1 whole squared. Send it squared to the other side with plus minus sign. Y plus 2 is equal to x plus 1. Shall I use plus or minus 1? Did I use the right flap? Yani, this is the left flap and this is the right flap. If I use the right flap, then positive sign. If I use the negative flap of the parabola, then I have to, with the square root, I need to use the negative sign. So he is using just this right flap, positive. So keep the positive sign here. And I'm going to write here square root of y plus 2 minus 1. So my inverse function, it is equals to square root of x plus 2 minus 1. Inverse function is also done. Then the examiner is asking you, show that f inverse is equal to x. It's pretty simple. F inverse of x. Basically, when the functions, you take the composition of function with the inverse function, they cancel each other and you get the x answer. But he wants to show, okay, what is my f of x? My f of x is where it is, x plus 1 whole squared minus 2, and my f inverse of x, which I have just found, square root of x plus 2 minus 1. The guy said find f inverse of x. What I'm going to do, I'm going to substitute f inverse. I'm going to substitute f inverse in f. So let's do it. F inverse in f. So I'm going to write it here in the place of x, x plus 2 minus 1, right? And then we have plus 1 whole squared minus 2. So minus 1 plus 1 cancel, square cancel with the square root. So x plus 2 minus, oh, wow, everything is cancelled. And I got f inverse is equal to x. Did you check that? This whole thingy was substituted in the place of x here. And then you saw minus 1 plus 1 cancelled, and square cancelled with the square root, and I got x plus 2 minus 2, and minus 2 plus 2 cancelled, and I got x. This is the thing which I wanted to get. Now the guy said, can you draw the sketch? This is very, very important for the exam, guys. When you draw the function with the inverse function, they are reflection of each other about the line y is equal to x. What is the dome given to you? You remember that was from 0 to 2. So 0, this was negative 1, and at 2, I got answer 7. The graph was like this. What was this point? That point was 0, negative 1. And that point was 2, 7. For inverse function, do you know what will happen? 0 minus 1 will change to, yes, come on, come on, come on, tell me what happens. they will be flipped, minus 1 0. And what happens to this point 2 7? It will change to, come on, 7 2. So minus 7 0, minus 1 0 is where? It is here. And where is 7 2? This is 7, and basically it will be here 7 2. So how the graph looks like? Oh wow, it looks like the reflection of y is equal to x. Can you imagine, guys? So this is your f inverse of x, and this is your f of x graph. And both of them must cut each other at this point, which is the common point of them. And that line has to be drawn in the exam, y is equals to x. So this is f inverse of x, and this is f of x graph, which was given by him. I flipped the points for f inverse. This is for f, and this is for f inverse, and I can draw the sketch. But don't forget, examiner will look into this, that did you cut both graphs on y is equal to x line? This is the most important point. And every point was flipped. This point is minus 1 0, and this point was 7 2. This is 7, and that is 2. It's a sketch. Now, am I done? Yeah, I'm done. Now, question number 11, he gave you a function, this function, quadratic function, x greater than equals to 2. We need to write it in completing this square form. So come on, guys, f of x, it is equals to 4x minus x squared. Let me write it in a beautiful form. First, I will write minus x squared. Don't change their signs, just keep minus x squared first, and then plus 4x afterwards, and plus 0. Can I use the calculator? I think allow me to use the calculator. How? I will write -1, enter, 4, enter, 0, enter. When I enter it, the first answer comes to me 4, ignore it. Second answer, ignore it. The next answer is 2. So if it is 2, I will write here x minus 2 whole squared. Next enter is 4 plus 4. So vertex, I know it is 2, 4. So with the help of this, I wrote the answer. But I know some of the students, they want to write it in the manual way. So the manual way is this. You write minus 1 outside, divided by 2. So x plus 2 divided by, remember, minus 1 whole square. What is this? This is minus 2. I'm going to write minus 2 whole squared multiplied with minus 1 plus 0. So this is minus x minus 2 whole squared. This is 4 plus 4. Wallahi, same answer comes. Anyways, after doing the completing the square form, the examiner says, can you find f inverse? Then you will again ask me, Mr. Omar, f inverse is possible only if there is no u-turn. Can I draw a rough sketch of this graph? It is 2 4, this is 2, and this is 4. Okay, and he is taking 2 greater than equal to x is greater than equal to 2. Oh wow, at the parabola, when I draw, because the parabola is like this, yes, there is no u-turn involved, because I'm taking from 2 onwards. And what is my range here? My range is from 4 onwards. Did he ask range? No, he didn't say. But the horizontal line test pass, it doesn't cut more than 1 times. So f inverse exists. Can I find f inverse? Let y is equals to minus x minus 2 whole squared plus 4. Let me try to make x as a subject. So the bracket has a negative sign. Can I send it to the other side? So I'm going to write here x minus 2 whole squared with a positive sign outside is equal to 4 minus y, and x minus 2. I know when I write the square root, I have to write the plus minus sign. Shall I use plus sign or minus sign? Did Mr. Omer use the right flap or the left flap? It's a right flap. So please keep the plus sign only, and send the minus 2 to this side. So x is equal to 2 plus square root of 4 minus y. So inverse of f is equals to 2 plus square root of 4 minus x. Done. Next, question number 12. I give you a function, linear function, f of x is equal to 4x minus a. I give you g of x function, it is b plus ax. Now, f of x and g of x, oh wow, he gave you f inverse of f of 1 is equal to 2, and inverse of 1, any inverse of g of minus 1 is minus 3. Wow, I'm gonna give you a trick. Can I send f inverse to the other side? Can I send inverse of g to the other side? Since it is a linear function, we are allowed to do this transformation. So send the f inverse to the other. What is the inverse of the inverse? Definitely say this is Mr. Omar, this is f of 2. Wow. Can I send the g inverse to the other side? Yes, it is becoming g of minus 3. So look, no need to find inverse functions. We can easily convert my f inverse to the other side. It becomes f of 2. So apply here. What is f of 2? That is 4 times 2 minus a. 1 is equals to 8 minus a. A is equal to 8 minus 1. So a is equal to 7. Here 1 is equals to b plus a minus 3. 1 is equals to b. What is a? 7 minus 3. 1 is equal to b minus 21. And then b is equal to 22. I found it. Next question, transformation. Lovely. Transformation, f of x is going to f, is transformed to this one. Describe the transformation. Clearly, it is horizontal translations. So what is the horizontal translation? Let me explain you guys about translation quickly. Translation. There are two types of translation: horizontal translation, and you slide something to the right, to the left, and there is a vertical translation, up or down. Horizontal translation may be 2 0, suppose, or maybe minus 2 0. It tells you 2 right or hina 2 left. If I do 0 2, it means 2 up. 0 minus 2, it means 2 down. How the function will be affected? Your original function is f of x. What will happen to this case? Horizontal is always opposite. If it is 2, I'm going to write x minus 2, and there is no vertical translation. If it is minus 2, I'm going to write f of x plus 2. Wow. So this is vertical translation, f of x plus 2. No need to change the sign. Vertical translation, no need to change the sign. This is minus 2. You write f of x minus 2. So in vertical translations, you need to write the number outside. Yani you have to add or subtract something with the output. But for the horizontal translation, you have to do something with the input. When you do something with the input, your meaning will be totally opposite. I think translation, I have explained it to you. So can you tell me what is the translation? Oh, x plus 5. So it means someone has moved minus 5 0, 5 left. If in the exam this question comes, 2 marks, translation, you can write 5 left. Or you can say that minus with minus 5 0. Next question. Next question is this. He said, like, what is this equation? Solve this equation. Okay, let's try to solve this equation. Uh, 3 plus f of x minus 1. Okay, can I throw x minus 1 in the place of x? X is what now? Please, guys, allow me. In the place of f of x, I'm going to write x minus 1. Do you want me to simplify? Because he used the word simplify. Open the brackets. So this is the simplified form. Wow, I know what happens. One right, one right, 3 up. Very good. It's a translation. Translation, 1 right, 3 up. Next question. Haha, minus 1. It means 1 left. How do I write it here? I will write y is equals to x plus 1 whole squared minus 3. Can I simplify it? X plus 1 minus 3. So x squared plus x plus x plus 1 minus 3. X squared plus 2x minus 2. Done. Beautiful. Now we are going to talk about another transformation, which is called reflection. Reflection. There are two types of reflection: x-axis or y-axis. In x-axis, output will change. Output will change the sign. In y-axis, input will change the sign. How? F of x, this is input and this is output. In x-axis, I need to change the output. So you need to write minus f of x. Your original function is f of x. When it is minus f of x, it means your point has been reflected about the x-axis. If I change the input, it means I'm reflected about the y-axis. Be careful, guys. Okay? So this is reflection. Let me go to the question. I have a point here, 3 minus 5, minus 3, 5. First of all, I need to understand what is this. It is because I am changing the input, so it is reflection about y-axis. It's a reflection about y-axis. So input is sign is changing. So input sign is changing. So I'm gonna write what? 3, 3, and the 5 will stay as it is. So the input is changing the sign. So 3, 5. Agreed? Minus f of x means it is a reflection about x-axis. So at this time, what will happen? The 5, the 5 will change its sign. Minus 5. In x-axis, don't get confused. In x-axis reflection, y coordinate changes the sign. Clear? This is interesting. The translation is happening, horizontal translation, and then you do the reflection. So I think I will suggest you guys, in this case, when I move from f of x to f of minus x plus 1, can you do it in two phases? Yani f of x first goes to f of x plus 1. That's better. That's better. X plus 1. And this is translation. I'm doing it. Translation is minus 1, 0. So I'm dragging my point to the left. So minus 3, I'm going to drag it to the left. It becomes minus 4, 5. Okay. So point P was minus 3, 5. It has been dragged left. And now it becomes minus 4, 5. Now the next thing is I am gonna do reflection because I need to change the sign of x. Reflection. So f of minus x plus 1. So when you change the sign of input, it means that the reflection about y-axis. So you have to change the sign of the y coordinate because it's you're changing input. Input means reflection about the y-axis. So what do you think, guys? What I need to do? I'm changing the sign of the input or the output. I'm changing the sign of the input. So if I'm changing the sign of the input, so it should become what? 4, 5. Imagine. Minus 4 becomes 4 because I'm changing the sign of the input. I'm not changing the sign of output. If I'm changing output, then it tells me the story. Anyways. So what happens here? First, I do horizontal translation. Then I go to the reflection about y-axis. Now here I'm gonna do again vertical. Um, Allow me, guys. First of all, let me do this reflection about x-axis, and then I do translation, vertical translation. And I will add minus 1. Suppose f of x goes to minus f of x, any reflection about x-axis. Reflection about x-axis, I need to change the coordinates of the y. So 5 minus 5. So minus 3 minus 5. I'm going to change it. Done. Uh, this one is done. Then I'm going to go to the next one. I want to do vertical translation. So vertical translation is it is telling me 5 down, 5 down. So 5 down means I'm going to change this minus 3. Further 5 down, it will be minus 10, minus 3, minus 10. Does it make sense? Minus 5, minus 10. I think you guys can do the same process here. When you do the reflection about y-axis, it means you are changing the sign of the input. So it is -2. I'm going to change it to 2 and keeping the y coordinate same. Then I go to the reflection about x-axis. X coordinate stays the same, the y coordinate changes the sign. Then I do f of minus x plus 1, in which I do the horizontal translation first. So horizontal translation means my x coordinate is -2, and I want to add one into it. Yani, oh, sorry, opposite, one left. So it has to be -2 minus 1 is -3. Got it? And I will keep the -8 as it is. Then after that, I have to do the reflection about y-axis. Again, I need to change the sign of the x coordinate, so 3 minus 8. Last one, which I have shown it here, I did the reflection first about the x-axis, so y coordinate changes the sign, so -2, 8, guys. And then after that, I uh, go with the vertical translation. I go 5 down, so -8 -5. When I go further down, I will stop at -13. So -2 and any vertical translation, I'm going to go -2 -13. I hope it clears to you guys. The x coordinate is not change. First of all, I change the y coordinates, so -8 becomes 8, and from 8 I need to go further 5 down, so that is -13. In this case, let me check it again. I was doing the horizontal translation. It was -4. First, I do the horizontal translation. That was +1, so -1. Did I do -1? Yes, I did -1 -3 -4, 5. And then I need to change the sign of the input. So -4 become 4, 5. So I think everything is clear. You can check from the marking scheme as well. Um, when I want to reflect anything about the x-axis, it means the whole output has to change the sign. So everything will be changed. So I'm going to write -3x squared minus 2x plus 8, because in x-axis, you remember f of x becomes minus f of x. So the whole equation will be multiplied with the minus sign. So state the equation of the reflected curve. So this is -3x squared minus 2x plus 8. Next is the graph y is equal to f of x is transformed to y is equal to -2 f of 2x. So now the time has come to talk about stretch. There are two types of stretch: horizontal stretch and the vertical stretch. Horizontal stretch and the vertical stretch both stands on scale factor. If you have original function f of x, horizontal is related with the input. If I write 2x, or if I write f of half x, keep it in your mind. And here vertical stretch is 2f of x, or half of f of x. Guys, here the scale factor will be opposite. I will say scale factor is half. Here the scale factor is 2. In horizontal, the scale factor is always opposite. However, in the vertical stretch, you multiply something with outside and your scale factor is the same. So scale factor is half. So vertical stretch and horizontal stretch we discussed. In this question, he said minus. He is doing two transformations. First, I need to do minus f. Yani I'm moving from f of x to minus f of x. Yani I do reflection about x axis, reflection about x axis, and then after that minus f, I do something with the input. I did the horizontal stretch. Yani I multiplied the here x2, the scale factor will be opposite, so it's a horizontal stretch with a scale factor of half. So these are the two transformations happen in front of us. Is it clear? You can write horizontal stretch first and then you reflect it about the x-axis. uh, any order you can choose to represent this transformation. Very important question from the examination point of view. you guys can see that there are three transformations happening. First transformation, which I can see easily here, yani f of x is going to 3f of x. Let me do it. 3f of x. So this is vertical stretch with a scale factor of 3, right? And then you do translation. You can combine it into as two transformations, but he wants three. So just you do horizontal translation first. So with a scale factor of 2, 0. Oh, sorry, 2 right. So 3f of x, if it is 2, I'm going to write minus 2. Then you guys do vertical translation, which is 0, 4. So 3f of x minus 2 plus 4. So these are the three transformations I have written in front of you. Question number 20. Here he has given you 3 points. X minus 2 tells you what? I'm going to translate my graph to right. So where it will go, 6, 0 will become 8, 0. 2 minus 3 will go to where? 4 minus 3. And 0, 0 will go to 2, 0. So when I draw the graph, it will be like this. What will happen? Minus f of x means I'm going to reflect my graph about the uh, x-axis because I'm changing the sign of the output. So no change will happen to b. It will stay as it is, minus 6, 0. But 2 minus 3 becomes 2, 3. So this is 2, 3. So your a 0, 0 will stay here. So the graph is like this. F of 2x, it means that it's a horizontal stretch. Your scale factor is half. So each point will be multiplied, the x coordinate will be multiplied with half. So take the half of that. So 6, 0 will become 6 divided by 2 is 3. So 3, 0. So your point is P is 3, 0. And 2 divided by 2 is 1. So it is 1 minus 3. So points will get more closer to the y-axis. 0 divided by 0. So you get the graph like this. Two things, reflection about the y-axis and the x-axis. So both coordinates will change the sign. So 6, 0 will become 0 minus 6. So 0 minus 6 is here. And 2 minus 3 is 3 minus 2. So 3, 3 minus 2. And next is 0, 0 will stay here. So let me check again my all points. 6, 0 will becomes I'm gonna change the points, change their coordinates. So 6, 0 will become 0 minus 6. So here I'm gonna write 0 minus 6. This is 0 minus 6. And 3 minus 2. 3 minus 2. And then we have 0, 0. What will happen to 0, 0? So 0, 0 will not be changed. So 6, 0, you guys saw that it becomes 0 minus 6, and 2 minus 3 becomes 3 negative 2. 0, 0 will become as 0. Why it is becoming 0, 0? Let me check it. I think we need to do transformation one by one. First, I have f of minus x. So I'm changing the sign of the input. So b6, 0 will become minus 6, 0. When I do minus f of x, so minus 6, 0 will stay as minus 6, 0. That's why the problem was happening. So the point is here. So minus 6, 0. Clear? And then I have another point when I do f of minus x with a point, which is 2 minus 3. That point changes to minus 2 minus 3. And then I do minus f of x on it. So I change the sign of, so it become minus 2, 3. So minus 2 and 3. So the graph comes to you like this. It is reflected about the origin. Okay. So this point is given, and I have shown this point minus 2, 3. And any this transformation was xy changes to minus x minus y, not minus y minus x. I think now it is free of errors. The last one is he gave you translation. What was the point I have? B is equal to 60. Translation is we need to understand 1 minus x first. We have f of x, and I want to do translation first. It becomes 3 plus f of x plus 1. Okay, so can I do this translation? So when I do this translation, it tells you minus 1 3. So minus 1 3 will make it 6 minus 1 is 5, and 0 plus is, so it reaches to 5 3. After that, I need to do a reflection about, I'm changing the sign of input. So this x will change its sign, so it becomes minus 5 3. I hope it clears. So minus 5 and 3. So the point will go here. Then after that, he gave me a point 2 minus 3. So 2 minus 3, I need to go left. So left 1 and 3 down, 1 0. Agreed? 1 0. And then I change the signs of the x coordinates as minus 1 0. So minus 1 0. This is the point. And where the 0 0 goes, the 0 0 goes negative 1, and then I need to go 3 up, so negative 1 3, and then finally it will become 1 3. Where is 1 3? This is 1 and this is 3. So the graph will become like this. Okay, guys, we have translation, we have also the reflection seen in this graph. Next question, number 20. He gave us two transformations. First, I think the best way is we want to do f of x to f of half x, which is telling you horizontal stretch with a scale factor of 2, and then after that vertical translation, which is 0 1. So f of half x plus 1. This transformation is moving from this point to this point. Can you count them? 1 2 3 and 4. He is moving 4 units to the right, 4 units to the right. But is he doing any, so this point 1 2 3 4. So this is the graph. If you translate it, yani f of x, translate 4 units to the right. How do you write it? F of x minus 4, and then scale factor, check it out, like this number, which is how much units away? 2 units away. And now this is becoming 6 units. It's not translation, guys. The shape is not the same as this. It's a stretch. It is vertical stretch. So 6 divided by 2, it gives you 3. The scale factor is 3. Every point has moved 3 times up, so scale factor is 3. So it's a vertical stretch because it is moving along y-axis. So I'm going to write 3f of x minus 2. What type of a transformation it is? This answer you should write it over here, and over here you should write that first it is translation, with 40, and then vertical stretch with scale factor 3. Clear? I can make you furthermore sure that this point is how much 6 6, and this point is how much, this point is 6 2. Did you see that 2 has gone to 6? So 6 divided by 2 gives you 3. The scale factor is 3. Question number 22. He gave you 3 minus f of x. So first from f of x you go to minus f of x. So when you go to minus f of x, this is a reflection about x-axis. And then after that you add 3 into it. So this is translation, basically vertical translation. And then he told you that f of x goes to f of 2x. So this is a horizontal stretch with a scale factor of half. And then vertical translation 0 minus 3. So f of 2x minus 3. There is a point 5x on the transformed curve, and you move from f of x, you move from f of x to f of 2x, and then you move from f of 2x minus 3. Your point is here 5 6. Can you find this point? And then you find this point. So this is the question mark. Here the scale factor was, this was horizontal stretch, you remember, horizontal stretch, scale factor was half. Here the vertical translation 0 minus 3. Can I start from here? I can write here xy, scale factor, this is horizontal stretch, scale factor half. Half means I need to multiply this number with half. You understand it? So half x comma y, horizontal stretch. Vertical translation, it is 0 minus 3. So you need to subtract 3 from it. So what it will become? It will become half x comma y minus 3. Am I right? Can you put them equal to each other? So half x is equal to 5. So x will become equals to 10. And y minus 3 is equal to 6. So y is equal to 9. Wow. So the actual point was what? So the actual point was 10 9. What happened to it? First you did the horizontal stretch, the scale factor half, you take the half of that, which comes to you 5 9, and then you do vertical translation, you took it 3 back, so it becomes 5 6. Is it the same question? So I found the question by using an algebraic way to get the original point um, on the original curve from the transformed curve. So here I'm done with the transformations. So whole function is explained to you. Inshallah, in my next video, I will explain you coordinate geometry.